Right, cool. Right, let's do it. So day 17. This one's on traffic analysis. I taught a C2 TAT. So congratulations, you've made it to day 17. The story, however, is just getting started. There is more things to discover, examine, and analyse. Until now, you've worked with multiple events, including prompt injection, log analysis, brute force, data recovery, exploitation, data exfiltration, suspicious drives, malware injection, account takeover, phishing, and machine learning concepts. Yes, there's a ton of anomalies, indicators of attack, and indicators of compromise. Santa's Security Operations Center, the SSOC, needs to see the bigger picture to identify scope, prioritize, and evaluate these anomalies in order to manage the ongoing situation effectively. How can we zoom out a bit and create a timeline to set the investigation's initial boundaries and scope? McSkiddy decides to focus on the network statistics. When there are many network artifacts, it's a good choice to consider the network in and out as well as the load statistics to create a hypothesis. Now it's time to help the SOC by quickly checking network traffic statistics to gain an insight into the ongoing madness. Let's go. Before moving forward, review the questions in the connection card. So today we just need to start the VM, which I've done, and there is a split screen. No attack box needed today again. So the SOC will give you a pre-configured VM for your convenience. The VM has a fresh version. Hey, thank you, Nop. How was your OS build? Let's give you a shout out as well, quick. Please give Nop a follow if you're not already. So yeah, we're just going through day 17 of the Try Hack Me room. So if you're not up to speed, this is the latest one for today. So yeah, we're going to be given a VM. It contains a fresh version of Silk, not Slick. It's also.
Thanks.
No worries.
Thanks.
Let's mute TTS a sec. Alright, so yeah, we're going to start the VM, discover the assigned analysis environment, and run the attached VM. Click on the Start Machine button in the top right, and then the machine will start in split screen view. If the VM isn't available, then the blue shows split screen, which again we don't need to do. So, right, the learning outcomes for today. We're going to gain the knowledge of the network traffic data format. We're going to understand the differences between full packet captures and network flows. We're going to learn how to process network flow data. We're going to discover Silk, the tool suite. We're going to gain hands-on experience of the network flow analysis within Silk. This is all new. I've never used this tool before, so this is going to be interesting. So network traffic data. Network data is everywhere. It's all around us, even now in this very task. Network communications and traffic are the natural behaviours of today's interconnected computing world. These behaviours represent a constant data flow of daily activities, including the personal interactions, business transactions. The data flow offers, let's put this on, invaluable network management, troubleshooting, instant response, and threat hunting insights. The table below highlights the importance and key benefits of each of these aspects. So network management. We're going to monitor the network performance, identifying bandwidth bottlenecks, and ensuring resource allocation and quality of service. Troubleshooting, identifying the network issues, latency and connectivity issues, validating the configuration, implementations and changes, and then setting the performance baselines. Instant response, so this is the incident scope, root cause analysis, assessment of compliance aspects of incidents and day-to-day operations. And finally, threat hunting, the proactive analysis for signs of suspicious, malicious patterns, potential threats, anomalies and IOCs, indicators of compromise. Also, behavior analysis is used to detect intrusions and insider threats. So network traffic comes in various data types and formats. Packet capture, or PCAP, also known as full packet captures, is the first thing that comes to mind. It provides a granular, raw, comprehensive view of the network traffic. This format provides all the possible data represented in packets in a ready-to-investigate format. This approach is also known as deep packet inspection. Therefore, it's an invaluable artifact for the network-level operation. However, this intensive resource needs storage, processing, and analysis capacities to provide comprehensive insights into network traffic. In other words, while a PCAP is very useful for detailed analysis, it's not practical for fast analysis situations as they enclose the actual payload. This situation becomes a pain point with large amounts of data and needs to be analysed. The data richness and level of detail provided by the PCAP format comes from the payload that it carries. At this point, it will be possible to speed up the process considerably by running the analysis process on a data format that doesn't enclose the payload data. As a result, it's possible to process more data in a shorter time with fewer resources, leaving more time for analysis and decision making. Network flow data is a lightweight alternative to PCAPs. It's commonly used in NetFlow format, a telemetry protocol developed by Cisco that focuses on the metadata part of traffic. In other words, it only provides the summary of the traffic. The details appear similar to how the call details appear on your phone bill. Once again, there are no packet contents within the format. This is why storing, processing, and analysing the data format is easier than it is with a PCAP. It looks like this format will help the team accomplish the task McSkiddy has assigned to them. A closer look at PCAPs and flows. So we take a closer look at these formats and see how they differ and understand what aspects are from each one. If you're still unfamiliar with networking terminology and the basics of this task, you can always get help from the rooms listed in the Network Fundamentals module. So yeah, do that if you're a complete noob to networking. But I think some of the earlier tasks did this, so you should be up to speed. So yeah, so PCAP has packet capture. This has protocol flow records. Depth of information, detailed granular data contains the packet detail and payload. Summary of the data doesn't contain the packet detail and payload. Then, hey, thank you for the follow. So this one does deep packet analysis. This has a summary, provides visibility of the packet detail, provides a higher level summary. Encryption is not an obstacle as the flows don't use the packet payload. Hard to process, requires time, resource, and store and analyze encryption is an obstacle. Contains a summary only and no payload. Layers, layer headers and payload data, just the metadata. The table above highlights the conceptual difference between a PCAP and network flow at high level. Now let's get into a more technical comparison of these two formats, understand why McSkiddy has chosen this approach as a quick solution for understanding overall network traffic activities. Elf Forensic McBlue explains the differences in the tables below. So we have we've got timestamp, packet length, MAC, IP, TCP, app layer protocol, packet data. So we do get IP, we do get the protocol, we get some flags, we get the size, timestamps, sensor information, and then more app level stuff. Cool, so we just lose like the MAC address and packet detail. So Forensic McBlue explains the significance between the PCAPs and network flow in the packet detail visibility and processing speed. Remember that McSkiddy wants statistics as soon as possible, so you're going to help the SOC team work on the network flow. To collect and process the network data. So network data collection and processing typically involves using network monitoring and analysis tools such as Wireshark, T-Shark and TCP dump to collect information about the traffic on the network and then analyze that data to gain insight, troubleshoot, or conduct blue and purple team operations. Also, product and system-based solutions will help collect network data in flow format. The specific tools and methods that you'll use will depend on the size and complexity of your network and your objectives. If you'd like to learn more about the network data capturing and analysis processes, the Wireshark module can help you get started. The SOC team tells us that they have some PCAPs and network flow records, but the available data needs to be more organised and ready for analysis. Luckily, one of our team members remembered a suggestion from McSkiddy. So, hint from McSkiddy, you can collect network flows and endpoints and network devices in the same way that you can collect a full packet capture. It's also possible to convert the PCAP into a network flow if you need a quick look at the network stats in a pre-recorded file. Many open source tools can help you read the network flow or convert the PCAP to network flow, and Silk is one of the most popular choices. So good news, Elf Forensic McBlue has converted all the traffic into a binary flow format, but we still need to discover how to analyse it. So a follow-up of the recommendations and exploration of tools. Let's continue with McSkiddy's suggestion and explore the use of Silk and help the SOC in this task. So Silk, or the System for Internet Level Knowledge Tool Suite, was developed by the CERT Situational Awareness Group at Carnegie Mellon University, their Software Engineering Institute. It contains various tools and binaries that allow users to collect, parse, filter and analyze network traffic data. In other words, Silk helps analysts gain insight into multiple aspects of network behavior. Silk can process direct flows, PCAP files, and binary flow data. In this task, you'll experiment using Silk tools on binary formats to help the SOC achieve their goal. Elflog McBlue gives us the network flow data in a binary flow format, so now we have enough data and sources to get to work. So getting started with the Silk Suite. The Silk Suite has two parts, the packing system and the analysis suite. The packing system supports the collection of multiple network flow types, IPFX, NetFlow 9, NetFlow 5, and it stores them in binary files. The analysis suite contains the tools needed to carry out the various operations, list, sort, count, and statistics on network flow records. The analysis tool also supports Linux CLI pipelines, allowing you to create sophisticated queries. The VM contains the binary flow format suspiciousflows.silk in the home Ubuntu directory, desktop directory. So there we go. You can verify this by clicking the terminal icon on the desktop and executing the following command. I mean, you can see it. It's there. I don't need to prove it's there. The next step is discovering the detail of the pre-installed Silk instance in the VM. Use the command provided to verify Silk Suite's installation. So this we do have to do. So terminal silk _config -v. There we go. Is there. Silk mainly works on the data repository, but it can also process data sources that are not in the base data repository. By default, the data repository resides within var silk data directory. This can be changed by updating the Silk's main configuration file. Note the task's primary focus is using Silk Suite for analysis, therefore we will only use the network flows that have been given by the SOC team. Quick win that helps you answer questions. You know which Silk version we are using, which is 3.19. Cool. Right, so flow file properties with Silk Suite. RW file info. One of the top 5 actions in packet and flow analysis is overviewing the file info. Silk Suite has a tool, RW file info, that makes this possible. Now let's start working with the artifacts provided. We'll need to view the details of binary flow files using the command below. So RW file info suspicious. It's going to let me tab. No, it's not. Let's CD into the desktop. Right, RW file info suspicious. There we go. Cool. So that spits that out. So we've got the format, version, little endian, compression, header lengths. These have been redacted, so I'm guessing these are tasks. Let's have a gander. Yeah, there we go. Right, which version of Silk is installed? 3.19.1. What's the size of the flows? I'm guessing it's the file size. Should be 152.366. No. Oh, count records. There we go. 11774. There we go. Count. Yeah, I saw count. I got it. Right, so where were we? Back to here. So the tool will help you discover the file's high-level details. Now you should see Silk's version, header length, total number of flow records, and the file size. Quick win that will help you answer the questions that we know. Okay, yeah, so we read that. So reading the flow files. RW cut. This reads binary flow records and prints those selected in the user in text file format. It works by reading and filtering the tool. For instance, you can open and print all the records without any filter or parameters as shown in the command in the terminal below. Note that this command will print all the records in your console and stop at the last record line. Investigating all these records at once can be overwhelming, especially when working with large flows. Therefore, you'll need to manage the RW cut tool's output. And you can do this by using the following command. numrex5. This will limit to the first 5 records and helps with the analysis process. Note that you can also view the bottom of the list with tailrec5. So we're going to run it again. -- num rex equals 5. Oh, it's not RW, is it? It's R cut. RW cut. There we go. Let's try and fit them all in. Let me stop there. Right, kind of overflows, but whatever. Alright, so up to this point, we read flows with RW cut, and now let's discover the filtering options provided by the tool. Recheck the output and the designed by column category. This means that there's a chance to filter some. RW cut has great filtering parameters that will help you do this. At this point, the -- fields parameter will help you extract particular columns from the output and make it easier to read. So we can stop it overflowing then by doing this. So we can do fields equal protocol SIP support and dip and dport. There we go. So then we only get the fields that we've requested. So this view is easier to follow. Note that we can filter out other columns using their flags and filter parameters. So we get duration, time, end time. Okay. So one more detail to pay attention to before proceeding is look again at RW cut terminal above and check the protocol pro column. Now you should have noticed that the numeric values under the protocol section 6666. The column shows that the used protocol is in decimal format. You need to pay attention to the section as Silk highlights protocols in binary form, i.e. 6 or 17, not in the keyword TCP or UDP. In the forensic aspect of the network traffic, every detail is presented by a numerical value. To master network traffic and packet analysis, you have to have a solid understanding of protocol numbers, including decimal and hex representations. Note that the IANA assigns an internet protocol numbers. Examples of TCP equals 1, IPv4 equals 4, TCP equals 6, UDP equals 17. A quick way to help us answer the question is to know the date of the 6 record in the given sample. So let's get the 6 record. Oh, we need the date as well. So what was the filter for date? We've got time. Does time give you a date? Let's have a look. S time, E time. Yeah, it does have the date on this. So let's go down and see if it's one of the questions. What was the S time? So we want the 6 record, S time. So we want this bit. Paste that in, there we go. What's the destination port of the 6 UDP record? We've got D port, so 3225. Oh, UDP, not so we want the port that is UDP. So we want. Well, let's go back up. There's probably a filter for excluding certain port numbers. Let's have a look. There we go. So this is what we want. So we've covered how to read and filter particular columns with RW cut. We need to implement a conditional filter to get extract specific records from the flow. RW filter will help us implement conditional and logical filters to extract records for event of interest. RW filter is an essential part of the Silk suite. It comes with multiple filters for each column of the sample you're working on. It's vital for conducting impactful flow analysis. However, even through RW filter, it's essential and powerful. It has tricky detail. It requires the output to be post-processed. This means that it doesn't display the result on the terminal, and as such, it's most commonly used with RW cut to view the output. We can view an example below. So we have to do a filter and then pipe it in. Okay, so let's go all the way to the start of this command. RW filter. Let's put my pipe in. And then what else are we going to put? So we want... Oh, we actually put the name in. So, and then we don't need it there, I'm guessing. Yeah, so we can take it out of there. Because it's being piped. And then... so the command is missing filtering and passing options. This is why we don't provide any result in the return. So we need to explore the potential filtering options and then pass them to RWCut to view the output. Remember Elf Forensic McBlue's hints on protocol and decimal representations. Let's start by filtering all UDP records. Good, that's what we want. So we want proto equals 17. And we're going to pass to standard output. And then that will go through to RWCut. Cool, so should be able to answer this now. Alright, what was the destination port of the 6 UDP record? There we go, copy you. That's better. So 49950, what was the record value of the D port? Okay, we're not there yet. Filter, we did you. So here we go. So we want some other things we can filter on. So let's go all the way back. So we want D port 53, I think it was in the question. And let's get rid of all of that. Yeah, we don't have a percentage. Maybe I've got to do something else. Let's go have a look. Oh yeah, stats. There we go. Let's be the next one. Okay, so we can filter on any port, source port, destination port. We have IP filters, so we can do source and destination addresses. We can search by number of packets and bytes. So now that we know how to filter and pass records to the post-processing with Unix pipes, we'll use an alternative filter option provided in the upcoming step. This section is a quick onboarding to make you comfortable with RW filter. We still need the big picture summary to decide on what to focus with. Let's consider this step as a preparation for the operation. We have the essential tools that we need to zoom in on events of interest. Let's discover some statistics and help the SOC team check out what's happening on the network. So yeah, we did this one. So quick statistics, RW stats. Up to this point, we've covered fundamental tools that will help provide some statistics on traffic records. It's now time to speed up things for a quicker and more automated overview of events. Before you start to work with RW stats, you'll need to remember how to use the field parameters that we covered in RW filter to fire alternative filterings commands for the events of interest. If you need help with using these parameters, return to the RW filter section and practice using the parameters provided. If you're comfortable with the previous tools, let's move on and discover the power of statistics. So this time we want RW stats, suspicious flow, fields deport, values, records, packets, bytes, SIP to distinct, DIP distinct, count equals 10. Cool, so that gets the count of the records, shows the measurement of flows in packets and bytes, shows the number of unique IP addresses, and the command shows the 5 destination ports that will help you understand where the outgoing traffic is going. So they've redacted the last one. So the quick win for that one, you need to know the statistics to follow the volume of the port number. So now that we have a better understanding of statistics with less effort, let's look at the terminal output above. It shows the top destination ports and the number of IP addresses involved with each port. This can help us discover anomalies and report our findings together to the SOC team. Remember, flow analysis doesn't focus on the deep details as you work on Wireshark. The aim is to have statistical data to help McSkiddy foresee the boundaries of the threat scope. So this one, so the value record of D port, so would help. Records would help if it was actually visible. Let's try and terminal. Right, let's change the font. I want it to be a lot smaller. Put it down to my head. We can go a little bit bigger than that. Let's try 9. That's alright, let's try 10. Perfect. Alright. Let's move it above my head, there we go. Right, so records. So what is the value record percent of the D port? So percent record 35. Does it want the whole number? It does. So copy, paste. There we go. Right, let's go back up. We did filter. We're done. Oh, these are more filters. So we want where's stats? There. Cool. Right, so assembling the toolset and starting to hunt for anomalies. Congratulations, you have all the necessary tools and have completed all the necessary preparation steps. Now it's time to use what you've learned and save Christmas. Let's start by listening to the top talkers on the network. So we need to do our stats, file name, fields, SIP, values bytes, count 10, and we want a firm top. Cool, so this gives us that. That's the number of bytes, so let's copy that quick. No, not paste, copy. And then this will answer the next question. Let's go back up. So if we check the percentage of bytes column, we've revealed traffic volume distribution and identified the top 3 top talkers. So on the network, let's list the top communication pairs to get a more meaningful, enriched statistical data. So we need to run it again. And this time we're going to add in DIP. And we want records, bytes, and packets. Count 10, we don't need the top either, so we can take that out. So if we have a look at this, so take a look at the percentage bytes and records column. These two columns highlight where the majority of the traffic originates. So again, it's overflowed annoyingly. Just about figure it out. So SIP and DIP, so these two are the most prevalent. Right, so yeah, so let's look at the two columns, highlight which ones where the majority of traffic originates. Remember that we found the last part in the RW stats and the high traffic volume was on port 53. Let's focus on DNS records and figure out who is involved. So we need to, one of these is redacted, so I can scroll up again, it doesn't matter. So if we look at we're running this one. So now we need to change stats again. So it's file name. This time we want a port equals 53. Pass to standard out. That should be RW filter. And then we're piping into RW stats. And then fields, IP, DIP, values, records, bytes, packets, count 10. So same again, just filtering on the port 53 traffic. So it's the top two. So we filtered all the records using port 53. The output shows approximately 99% of all the DNS traffic occurred between these two IP addresses. That's a lot of DNS traffic. And it's abnormal unless one of these hosts is a DNS server. Even though the traffic volume doesn't represent ordinary traffic, let's view the frequency of requests using the following command. So here we want to do RW filter, suspicious flows. We want S address, so source address. IP here, so we want the IP. Let's copy the top one. Destination port is 53. Pass to standard out. Pipe. And this is going to RW cut. Fields equals SIP. DIP. And S time. Then pipe to head 10. Just like that. Minus 10. There we go. Right, so this gives us a red flag. So we have the there we go. So over 10 DNS requests in less than 1 second are anomalous. We should highlight this communication pair in our report. Note that we filtered out the second talker, which ends with 211. It's the source address of the first communication pair. Let's look at the other IP addresses with the same command. So here we go. So we've got to run the same thing. And let's put in the other IP. So this one was 243. Oh, didn't like that. I missed one. So it should be did I put 175.219.238.243? That's better. So that didn't give anything. Second command provided 0 result, meaning that second IP didn't send any packets over the DNS port. Note that we will elaborate on these findings in our detection notes. One final check is left before concluding the DNS analysis and proceeding with the remaining connection pairs. We need to check the host that we marked as suspicious to see if the other hosts on the network have interacted with it. Use the following command: RW filter suspicious flows any address equals 175.175.173.221 and pass standard out, pipe RW stats, fields, SIP, DIP, hyphen values equals records, bytes, packets, and count equals 10. So if we look at the command result, it says one more IP interaction ending with 99. And we'll focus on this new pair by overviewing the communicated ports to identify the services. So for this one we have to do RW filter, suspicious flows, any address, 205.213.108.99. Oh, it actually gives you the thing in the output. Why do they obfuscate it here and then put it there? Anyway, right, pass equals standard out, and then pipe that to RW stats hyphen fields equals SIP S port DIP D port and count equals 10. Okay, so that gives us those four. These four records are on port 123. So in there. We can mark this as a normal service since there's no high volume of data on it. Remember that port 123 is commonly used by the NTP service. From the volume it looks just as though it should. Up to this point we've revealed the potential C2 over DNS, and we can elaborate on these findings in our detection notes. The communication pair that uses DNS port is suspicious, and there's signs that there's a C2 channel using DNS connection. The elaboration points are listed below. The source IP address ends in 221. It sent massive DNS requests in short intervals. This pair must be analysed at the packet level. According to the flows, the destination address has a higher chance of being a DNS server, and this means that the source address might be an infected host communicating with a C2. DNSCat2 is a tool that creates C2 tunnels over DNS packets, so it would be helpful to consider generic patterns created with DNSCat2 or a similar tool in further analysis and detection phases. Did we find Tracy McGreedy's C2 channel? So now let's continue the analysis and discover if there are any more anomalies. Remember the quick statistics RW stats where we discovered the massive volume on DNS port. That section also highlighted the volume on port 80. Let's quickly check who is involved in that port 80 traffic. So you RW filter suspicious hosts A -A port equals 80, pass to standard out, RW stats, fields, SIP, DIP, count equals 10. So we get that. And we listed all the connection pairs that created noise. Let's reveal one of the created, one that created the load by focusing on the destination port. So we want to run the whole thing again. And then this time we want the, that's the same thing I just ran, isn't it? 480. Oh, it just includes the port. So we want, so add in D port. Now we get the port numbers. Now that we've created a list of all the addresses that use port 80 and revealed the addresses ending in 236223, there's a load. but one that created the noise by sending the request. Remember that we don't have the payload to see the request detail, but the flow details can give some insights about the pattern. Let's view the frequency and flags and the request to see if there's any abnormal pattern there. So this one we'll do RW filter, suspicious follow, S address, (175.215.236.223), and I didn't finish the fucking command. Pass equals standard out. Pipe that to RW cut. Fields equal SIP, DIP, dport, flag, S time, and head. I didn't like that. Oh, because I didn't put a comma there. There we go. So that gives us that. We can see a series of SYN packets that have been sent in less than a second, and this needs attention and clarification. Let's view all the packets sent by the host first. So RW filter, suspicious flow, S address 175.215.236.223. Pass standard out. And this is going to RW stats. Fields equals SIP flag DIP. That equals 10. So that gives us that. If you look at the results, no ACK packet has been sent by the host. This pattern is starting to look suspicious now. Let's take a look at the destination's answers. So again, RW filter. We can probably just use the previous one. So we don't need S address. We want fields SIP flag DIP count. Nope. Filter. Is that not what I did? How does that differ? So we've got S address 1.5.252. Oh, different address. There we go. So it's 215.235. There we go. So that one had an ACK. So the destination address was sending a SYN ACK packet to complete the three-way handshake. That's expected. However, we have already revealed that the source address only sent SYN. It's supposed to send ACK packets after receiving a SYN ACK. To complete the three-way handshake. That's a red flag as it looks like a DOS attack. We'll elaborate on this in our detection notes, but we still need to check if the host has interacted with other hosts on the network using the following command. We want exactly the same thing. Change S address to any address. And then we want the 236 box. And same number of stats. We don't want flag in this case, just source and destination. So luckily there were no further interactions, and we can conclude that the analysis and elaborate on the findings in our notes. So the detection notes, not a water flood. The connection pair that uses port 80 is suspicious. There's a sign that it's a DOS attack. Elaboration points are listed below. The source IP address ending in 236.223 sent many TCP SYN packets in short intervals. The suspicious address didn't send ACK requests representing the TCP three-way handshake process. There's a high probability of a SYN flood attack. Who is trying to DOS that particular host and why? Is the host compromised or do we have an insider? So congratulations, we've helped the SOC team identify the network statistics and reported the potential anomalies to McSkiddy. In this task, we've covered the fundamentals of network traffic data and analysis process. We've also explained the two standard network formats, PCAPs and network flows. We've demonstrated how to analyze network flow data using the Silk suite. Now practice what you've learned by answering the right. So we've got 4 more questions to get. So what was the S time value of the first DNS record going to port 53? So that will be back up here. Probably one of these. Here we go. So the S time value of the first DNS record. That will be U. So let's copy that. What was the IP address of the host that the C2 potentially controls? Oh, we have to give it in defanged as well. So the IP. That was this one, wasn't it? Copy U. Let's defang it. We'll just wrap all the dots in square brackets. Not that one. Alright. Port 80. What was the host that the C2 potentially controls? It was the one with DNS records, wasn't it? Three five, maybe? No. What's the first question? So it's got to be this one. So what's the source IP? That was the safe one. It's this one, wasn't it? So 175 173 221. Yeah, cool. Which IP address is the suspected flood attacker? This was the one I wanted, so that's the one I just removed. I could have copied that in a way. Copy, paste, and defang. What is the SYN packet's number of records? So that was that one. Cool. We've successfully analysed the network flow to gain quick statistics. If you want a deeper dive into network packets, network data, you can look at the Network Security and Traffic Analysis module. Oh yeah, this is definitely a paid one. So yeah, all the paid ones have the VIP badge on. Not bad. Yeah, I quite like that one. Bit more tricky than the previous ones, but that's to be expected on day 17. Let's terminate the box, save them some AWS dollars getting wasted.